Hi, this is Shiyu from MEMS 5001, and today I'm going to give a final presentation about my project. My project is optimization of automatic parking strategy, and let's first recap the problem. Well, the space between L1 and L2 is the road, and BCED is a parking space, and our car is somewhere in the road, and our job is to park the car into the parking lot. First, a XY coordinate system has been built, and the origin is at the midpoint of BD. Usually, the parking procedure can be separated into 3 steps. We assume the car is parallel with the road at the beginning, which is at the position 0, and step 1 is from position 0 to position 1 with some constant steering angle, or say some constant turning radius R1. Since steering angle and turning radius are always related by Archimedes steering geometry. Step 2 reverse from P1 to P2 with another constant radius. Note that the car is parallel with the parking lot at the end of step 2. So step 3 is simply reverse straightly from P2 into the end of parking lot. So the track is actually controlled by x0, y0, r1, r2, and alpha. Or say x0, y0, steering angle 1, steering angle 2, and alpha. The first objective of my project is to find the feasible start position, or say where the x0, y0 could be. And the next objective is to find the best parking strategy, or say the optimum r1, optimum r2, and optimum alpha for a given start position x0 and y0. The constraints for this problem are mainly at the upper boundary of the road L1 and the entrance of the parking lot. We have to pay attention to that the constraints are different depends on the coordinates of O2. We have 2 different constraints depend on x coordinates of O2, and 3 different constraints depend on y coordinates of O2. So there are in total 2 times 3, which is 6 different situations. All the situations are shown in the slide following. To try to find the feasible start position, I use Eclipse to try all the combination of x0, y0, r1, r2, and alpha, and check whether they satisfy the constraint. Once they satisfy the constraint, I will print out the x0 and y0. Then I import all the x0 and y0 into Excel, and I got figure like this. So in this figure, each tiny point represents a feasible start position. And it's very obvious that this line is y equals 1. And to figure out the mathematical expression for the left curve and right curve, we need to delete all the points in the middle and fit the curve. So this is the result for the left curve, and this is the result for the right curve. So basically, if you park the car in the 3-line enclosed, you can always find parking strategies. Next is to optimize the strategy for a given start position. Well, this part is done by JA Solver in MATLAB. This is the 6 constraints I mentioned before, and they will be called by the main code. In the main code, this part is to initialize the parameters of the problem. And this is our fitness function, which is a linear summation of 2 parts. The first part is the length of the track of the 3 steps, and the next one is the distance between the center line of the car and the center line of the parking lot. Or in other words, we want the parking procedure be both quicker and safer. This part is iterations. And in each iteration, the 6 different constraints will be solved. So basically, when you run the code, you will be asked to input x coordinate of the start position, let's say -3, and y, let's say 3, and times of running GA. I don't want to consume too much time, so let's say 1. And the result will be shown in the command window. Sorry. So the result for each situation, each condition is shown in the command window. And when the code executes, a figure shows the fitness function value for different condition was shown, and the best parking strategy with minimum fitness function value among all the results will also be printed out. It's here. See, for a given start position -3, 3, the optimum steering angle in step 1 is the optimum turning radius in step 1 is the optimum steering angle in step 2, the optimum turning radius in step 2, and the optimum alpha. So when you run a code for a different start position, you will get a chart like this. So that's all the main idea about my project, and I think the advantage of my project is that the parameters of the car and parking lot are always ready to be changed for another different problem. So my work is very universal and general. Thank you.